match the char pointer. If you have something that returns an int, C might allow you to do that, but it doesn't match up. And therefore, doing something like this is equally as dangerous as forgetting this altogether, because these are basically like puzzle pieces that need to line up. So you have the char star, and the other one returns the char star. And basically, they fit together. If you do something wrong here, like bugs are already all over the place. If you have something like a normal char, the default value to initialize this to is the \0 character. Now I've seen people putting the 0 in here, which works, but it doesn't mean the same. I've seen people putting a 0 in here, or maybe a null in here. And this is also a pretty bad mistake to make, because chars are technically characters. Even though they could be represented as numbers, what we're talking about is we want a character, some kind of letter or sign, like the $sign or something else. If you put a number in between here, the computer might make assumptions on what this number refers to. Like the star character is actually the number 42, but nobody guarantees that this is actually the case on other systems. So you recompile the thing, and maybe this might be character number 43, and if you put 43 in here, you might end up with a different character altogether. So this is everything that's related to initialization patterns. All the different errors, all the different kind of mistakes that you can make, they are all rooted within initialization patterns. So whenever you see something like a segmentation fault, it's often the case that you have put a weird value into a string. Or whenever you see a function that should actually skip over white spaces, as in our friendly atoy function, whenever you have a function that should actually skip over these, but you wrote something like while str equals 32, which is actually the number corresponding to the space, what's going to happen is, if this number changes, your while loop might just leave the spaces in between here, because now we're using the number 33 for these spaces, and you didn't know. You didn't put the space in here, so the system will just assume that, oh, it's a different character you meant, so maybe the star. And of course, the system will misunderstand you in such cases. And whenever you have some kind of while loop that doesn't terminate, it often happens because you put a wrong number into its condition or into a variable that's related to that. So initialization patterns are the source of these kinds of errors. And whenever you see these, look at these patterns. Make sure that first the declaration comes, second the initialization, that they match up, and that you really have the exact type that corresponds to it. Does this make sense to you? Okay. Do you have experience with these types of errors? Have you ever had a bug so severe that you spent an hour or 2 hours in front, or maybe even more, in front of the computer, and you were just wondering, why doesn't my loop terminate here? Why don't I get results? And have you seen yourself doing something like this before? Might not even be this error, or putting maybe a 0 instead of a null, and just wondering why something weird happened. Like, do you have experience with these types of errors? Okay, that's good, because if you don't, then you really have done things well with our patterns, which is quite unusual actually, because like even the most experienced programmers will still boil their code down to these patterns. They might look like a bunch of randomness in the beginning, so why would I care about these two things matching up? Like, why do I care about 0 and null? Why just put a 0 here and just leave things the way they are? Programming is mostly about being precise in what you mean, and patterns and having some kind of space in between where you put some code blocks in. Like, patterns are really important, but connecting patterns in a way that things work out is also a different and difficult part that you need to pay attention to. So not only is it about fitting some random patterns inside of each other, but what's also important is that this one matches this one matches that, or that, so that like patterns have some rules of how they interact, what to put where. There are some hidden rules, and if you don't get them straight, the system will not punch you and tell you that you did something wrong, but sometimes you might get some weird mistakes and you can't figure out why. And in most cases, it's because you have violated some kind of hidden rule inside of these patterns. Okay, so much about initialization patterns. What happens if something goes wrong and it wasn't a pattern fault? For example, you have a function that looks like maybe the str_dub. That takes a char pointer, and the function works well. But what happens if I put the null pointer in here and it crashes? You get a segmentation fault if you put a null pointer in str_dub. Like, I think the libft tester does this and tells you with a crash or emoji sign that str_dub isn't protected against null pointers. Have you seen this error before? Like, we have the libft tester, which runs your libft code, and in some situations you might get an error message that looks like your code isn't sufficiently protected against null pointers or segmentation faults. Now, if you see this kind of error, it might be related to the initialization, but sometimes it might also be the case that your code has some assumptions about the variables that just can't hold in the circumstances, and I'm going to explain that now. So, are you familiar with this kind of error? Okay, if you people are not, so let's get into detail here. Because the second kind of pattern that I'm going to talk about are the guard patterns, and they are basically coming after the declaration and initialization. Guard patterns are really important. So let's say you were to write a function that takes the string length. So you have the size t, string length of a string. And let's say you had some kind of weird mix of patterns in here. We don't care about that. But whenever you call strlen of null, which basically means nothing, no string, your code crashes. Why does it do that? Any ideas? Like, I think most of you are familiar with that. Who isn't? Okay. Now, whenever you see your program crashing or your tester telling you that you are not null protected, what's happening here is somewhere deep in your code, you do something like this. Maybe. I don't really know, but something like this. And this is the part where things go wrong. Because this star basically means I have a pointer here, I want to look into that pointer. So this is a string, and I want to say, okay, I have the string ABC, we're pointing this character, this is our str, and now I want to get the character we are pointing to. So in this case, it would give me A. If I were pointing towards this character, it would give me B. But what happens if I put null into str? Then I'm not pointing towards anything. And when I want to follow this, in order to get this with this expression, a crash happens. And whenever you see something like this in your code, and you notice that your code crashes when you put null as a parameter, this means that you haven't protected yourself against these cases. You always assume that this pointer is going to point towards a perfectly valid string, but you haven't ensured that it's not pointing into some kind of rubble here, which is also called null. Yeah, how do you avoid these cases? They are pretty easy to avoid if you know when they happen, and they usually happen in these situations. You get a function with a pointer parameter, and you do something with that parameter, dereferencing it here. What do? There's a pattern that I need a bit more space for, that looks like this. If this this is a pattern which is called a guard pattern. And what these patterns do is, right here, in this position of your code, str could be valid or invalid. It could point to null. It could also point to a string. And now this case tells the system, if you notice that this string is pointing, or that this pointer is pointing towards such a weird bunch of data that I cannot dereference, then I'm going to break out of the function and return 0. Again, 0, this 0 matches this type. I'm going to break out with value 0. So whenever I put strlen of null, it will just give me out the 0 instead of running this code. Yeah.
Is this the same thing like saying if !str?
This is, right, good question. And this is exactly what I meant with this. A few people use, and this is why it's so important to know patterns, because let's say you wrote, I think this is what you meant.
Yeah, exactly.
This is a shorthand that C provides, an abbreviation. This exclamation point means exactly the same as if str equals 0. But it doesn't check against our magic null. It might be true that on some systems, null is encoded as the number 0. Technically, internally, somehow the number null, the value null and the number 0 are specifying the same thing. But on some systems, null might actually map to the number 1 or to the number -1. There are systems that do this, and if you write this, your code might, on some random occasion, crash. Maybe not always, maybe not at all on Macs, but maybe on Windows machines, maybe not on machines that are younger than 20 years, but on older systems it might crash. So you get some kind of weird behavior out of this, which might or might not work. It's like the worst thing is not code that